So, welcome to our revision tutorial looking at how to calculate specific heat capacity. So, if we start with calculation of specific heat capacity, remind ourselves what it means. Now, specific heat capacity in terms of a definition, overall, it means, and it describes the amount of energy, needed to raise 1 kilo of a substance by 1 degree Celsius. So our equation as a whole looks at the following. Now, with any equation in physics, it's worth bearing in mind that you have to be able to rearrange it to calculate different parts of it. And we'll look at that further down in this tutorial. So we start with what the overall equation means. Now, first term here, our symbol, describes the amount of energy transferred. Now, as with any measurement of energy in physics, it's described as in terms of joules. M refers to the mass of the substance being heated, which is measured in kilograms. Theta here, the symbol, refers to the change in temperature of the substance. Which is measured in degrees Celsius. And then C refers to our specific heat capacity. Now, sometimes in questions we are given this, sometimes we're asked to calculate this. We're going to look at this as we go through this tutorial. But in terms of the overall equation, this is where it fits in. And specific heat capacity is measured in joules per kilograms degrees Celsius. So we've got our equation there. So if we have a little look at an example of what we mean by specific heat capacity. So if we take our little example, we've got 1 kilo of water that is 26 degrees Celsius. Okay, so if we're wanting to heat that water so that it becomes 27 degrees Celsius, we need to apply a certain amount of energy to it. Now, this amount of energy depends on the bonds between the different molecules and within the atoms of the substance that you are heating. But in the case of water, if you apply 4,200 joules of energy to 1 kilogram of water, you are going to increase the temperature by 1 degree Celsius. Now, that, therefore, is our specific heat capacity, because it's the amount of energy that we need to heat this substance by 1 degrees Celsius. Okay, so 4,200 joules per kilogram degrees Celsius would be our specific heat capacity of water. Good. Now, same idea. If we wanted to actually take 27 degrees Celsius of water, that's 1 kilo, and we wanted to heat it so that it was actually became 29 degrees Celsius, we need to apply a certain amount of water, a certain amount of energy, sorry. Now, Bearing in mind that we said we need 4,200 joules of energy to heat 1 kilo of water by 1 degree Celsius, you can probably work out that we need 2 lots of 4,200 joules of energy to heat it by 2 degrees Celsius. And that's because the specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. So if we've got 2 kilos, 2 degrees that we want to heat it by, we're going to need in total 8,400 joules of energy. So that's what we mean when we're referring to specific heat capacity, the amount of energy needed to heat 1 kilogram of a substance by 1 degree Celsius. We can apply this to different contexts. So let's have a look at some examples. So you can go through these work examples with me as we go. So if we think back to our equation, so we've got change in energy equals mass times specific heat capacity times change in temperature. So if we bear that in mind. So if we look at our example here, what we're looking to try and do is we're going to imagine that these squares are water. I'm going to ask you to calculate the energy transferred so our E into the water. So we're given certain bits of information. So our specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. We know that. That's a set figure for water. Now, if we've got 1 kilo of water, start is 6 degrees Celsius, and then that kilo of water is heated so that it becomes 12 degrees Celsius, we can use the information that's provided here to calculate the energy that's been transferred into the water by putting numbers into this equation. So let's go through it. Well, energy transferred, what is it? So what's our mass of our water? We know it's 1 kilo. That mass doesn't change. Times our specific heat capacity, which we know is 4,200 joules per kilogram degrees Celsius. Now, what is our temperature? So, what was the temperature at the start? What was the temperature at the end? What's the difference? So we know that our temperature change, difference would be 12 minus 6. So overall it would be 6, wouldn't it? So 1 times 4,200 times 6 give us change in energy of 25,200 joules. So that's the amount of energy that's transferred into 1 kilogram of water to heat it from 6 to 12 degrees. We've got an example there. Let's have a look at another example. But bear in mind, we've said that different substances, due to the bonds between those different molecules in those different substances, basically mean that different substances have different specific heat capacities. So, for example, oil, it has a specific heat capacity of 2,100 joules per kilogram degrees Celsius. So in that respect, that actually means that oil requires less energy to heat 1 kilo of the substance by 1 degree Celsius. So let's do a similar example. Calculate energy transferred into oil. So we've been given our specific heat capacity here. And in our question, we know that we've got 5 kilos of oil, starting temperature of 83 degrees Celsius, and that 5 kilos of oil is heated to 96 degrees Celsius. So let's put our numbers into our equation as we did in the previous example. So energy transferred equals 5 kilos times our specific heat capacity of 2,100 joules per kilogram degrees Celsius times our temperature change. So we know that our temperature change would be 96 minus 83, because that's the difference. So overall, that's going to be 13. So it becomes 5 times 2,100 times 13. Means our energy change overall. So the amount of energy put into 5 kilos of oil to heat it from 83 degrees Celsius to 96 degrees Celsius would be 136,500, because it's energy, be joules. Good. So hopefully we're starting to get a bit more of an idea and an example. So let's have a look at another third one, okay? So if we have a look at calculating the amount of energy that's transferred into concrete. So the specific heat capacity for concrete is 850 joules per kilograms degrees Celsius. So we've got 650 kilos of concrete, and it's heated from 43 degrees Celsius. Well, I say heated, the temperature changes from 43 degrees Celsius to 20 degrees Celsius. So energy isn't being transferred into the substance here, energy is being transferred out. So we're wanting to calculate the energy transferred out of the concrete. Now, even though it's a drop in temperature as opposed to an increase in temperature, it doesn't matter. Still carry out the same steps as our previous examples. So, our energy transferred. What's our mass? 650. What's our specific heat capacity? 850 joules per kilogram degrees Celsius. Times our temperature change. So 43 minus 20. So our energy transferred becomes 650 times 850 times 43 minus 20 times 23. So our energy transferred out of concrete becomes 12,707,505 joules. Brilliant. So we've got 3 worked examples there. So let's have a little look at some more where we can change and sort of manipulate the equation slightly. So if we think back to water, and we know that if we've got 1 kilo of water and we want to increase it by 1 degrees Celsius, we have to input 4,200 joules. Now, question is, what would happen, for example, if we wanted to increase 4 kilos of water by 2 degrees Celsius? So if we think 1 kilo by 1 degree Celsius requires 4,200 joules of energy, it means that for every kilo we want to be applying 4,200 joules of energy for 1 degree Celsius. So if we want to increase a kilo by 2 degrees Celsius, we need to apply 2 lots of 4,200, which, as you know, becomes 8,400. And if we've got 4 kilos, so 4 lots of this, we simply need to then multiply it by 4. So increase 4 kilos of water by 2 degrees Celsius means we've got 4,200 joules times 2. So we've got each of those, so it becomes 8,400. But then we have to multiply that by 4, which ends up giving us, if we do that quickly, 8,400 times 4 gives us 33,600 joules. So another example of how we might apply it slightly differently. Then, the final thing for us to be aware of is that we can rearrange the equation. So if we rearrange the equation, we can actually come up with a way of working out specific heat capacity. It becomes the amount of energy transferred divided by the mass times the temperature change. So if we take an example where we've got 3 kilos of copper at 8 degrees Celsius, and we have got 3 kilos of copper at 31 degrees Celsius, and we know that in order to change that temperature, we've had to apply 26,565 joules of energy. So if we've got that, we can then use those figures to work out these 3 terms. So we know that our change in energy equals 26,565. We know that our mass equals 3 kilos. And we know that our temperature change, our difference in temperature, so 31 minus 8 becomes 23 degrees Celsius. So all we're left with doing is plugging these numbers into our equation. So we end up with specific heat capacity equals 26,565 divided by 3 times 23, which gives us an overall specific heat capacity of 385 joules per kilograms degrees Celsius. And that is our specific heat capacity of copper. That's how we can change the equation to actually work out the specific heat capacity, and not just the energy transferred. So let's have a look at 3 examples of that to finish off. So if we take 2.5 kilos of lead, and we know that it's 20 degrees Celsius, and we apply 19,500 joules of energy, and that 2.5 kilo block of lead is heated to 80 degrees Celsius. So think through the steps from the previous equation. We know that our energy transferred divided by mass times temperature change. So we know then that our energy transferred is our 19,500 joules. We know that our mass is 2.5 kilos. And remember, our temperature changes our difference, so it's 80 minus 20 gives us 60. If we work that out, we end up with a specific heat capacity of 130 joules per kilogram degrees Celsius. So our specific heat capacity of lead here is 130 joules per kilogram degrees Celsius. Brilliant. Now, we've got one example, so let's have a look at another example using that same principle. If we have 200 grams of water at 4 degrees Celsius, and we apply 40,320 joules of energy, and that 200 grams of water is heated to 52 degrees Celsius, what would our specific heat capacity of water be? So, we know from previous questions the specific heat capacity of water is 4,200. But can we prove it using this example? So, we take our specific heat capacity, our energy transferred, 40,320, divide it by our mass. Now, this is 200 grams. Now, in mass, it needs to be kilos. So 200 grams converted to kilos becomes 0.2 kilos. So remember, it needs to be in kilograms. As we said, kilograms was our original unit. So 0.2 times, what's our temperature difference? Change in temperature. 52 minus 4 will give us 48. So if you do 0.2 times 48 and divide that answer by 40,320, you'll find the answer comes out as 4,200 joules per kilogram degrees Celsius, which we know is specific heat capacity of water. This question helps prove that fact. Then if we look at one final example using the idea when we came across oil. So if we go with 800 grams of oil at 100 degrees Celsius, and we apply 140.8 kilojoules. And remember, that's 140,800 joules. 800 grams of oil becomes 12. And when we say apply, it's the amount of energy that's lost. So remember, our energy needs to be in joules. So 140,800 joules converted. I put those numbers into the equation. C equals 140,800 joules divided by 0.8 times 88, because the difference between 100 and 12 is 88. If you put those answers into a calculator and see what we come out with. So 0.8 times 88 gives us 70.4. So 148,800 divided by 70.4. 800 divided by 70.4 gives us 2,000 joules per kilogram degrees Celsius. which is our specific heat capacity of oil in this question. So, several worked examples. This should give you an idea of how to calculate specific heat capacity and how to calculate energy transfer using the specific heat capacity equations. Thank you for watching the tutorial.